Welcome to Brain Vision.
Hi. In the given problem, the spilled isotope is 131 beryllium and its decay rate dN by dt is given as 400 microcurie. We know this conversion factor of micro is actually 10 to the power minus 6. So, this decay rate of the isotope spilled in the laboratory is 400 into 10 to the power minus 6 curie. Now, in order to convert this curie into decays per second, we multiply it by 3.7 into 10 to the power 10. Now it becomes decays per second because we know the rate of disintegration means 1 curie. If it is given as 1 curie, it is equal to 3.7 into 10 to the power 10 decays taking place per second. So here this is the rate of disintegration of the beryllium. Now the half-life of this beryllium here is given as 12 days. So in the first part of the problem, we have to find the mass of the beryllium which was spilled in the laboratory. So to find it, we simply use the relation for this decay rate in terms of decay constant, which is given as the product of decay constant with the activity of the sample at that time. Means it will be equal to, it will be given as not the activity, it will be given as the number of atoms at that time and not the initial number of atoms. So the initial number of atoms and not will be given as 1 by lambda into dN by dt. Now here decay constant is lambda is equal to 0.693 by T half. So if we place it here, this number of atoms will come out to be 1 by 0.693 by T half into dN by dt, or we can say this is T half divided by 0.693 into dN by dt. Again, using the concept of moles, the number of moles of the radioactive sample will be given by mass of the sample divided by its molar mass, which is clearly 131 gram as given here. So if the number of moles is this, so the number of atoms N naught will be moles into Avogadro number, because we know the number of atoms in 1 mole is equal to Avogadro number. So N naught means the total number of atoms here will be the total number of moles multiplied by Avogadro number. So here it will become mass into Avogadro number AV divided by molar mass. So the mass of the sample will come out to be number of atoms N naught into molar mass, then divided by here mass is equal to N naught into molar mass divided by Avogadro number. And for N naught we use this expression. So here it comes out to be T half divided by 0.693 into dN by dt into molar mass and finally divided by Avogadro number. So finally plugging in all known values, the mass of the sample here will come out to be 12. If we put all the values one by one, For half-life, this is 12 days. So this is 12 into 24 for dN by dt. This is, no, first of all we will have to convert this 12 days into seconds. So 12 days into 24 into 60 into 60 seconds. This is the half-life in seconds, divided by 0.693. Then dN by dt, 400 into 10 raised power minus 6 into 3.7 into 10 raised power 10 into 131 for molar mass, and for Avogadro number this is 6.023 into 10 raised power 23. So if we calculate all these things, it comes out to be 4.82 into 10 raised power minus 9 gram, or we can say this is 4.8 nanogram. This is the mass of the sample which was spilled in the laboratory, and it becomes the answer for the first part of the problem. Now, in the second part of the problem, we have to find the time for which this lab should be closed, because the safe level, the radiation level, recommended radiation level is given as A is equal to 1.00 microcurie. So to get up to this level, we have to find the total time. So we will use the expression for the time which is given as 2.303 divided by lambda, again log A naught by A, where A naught is the initial activity, means the decay rate, which is 400 microcurie, and A here is 1.00 microcurie, and this time we will not convert curie into decays per second or per days, because it will be cancelled from numerator and denominator. Now this is 2.303 divided by 0.693 upon T half into log base 10. This is base 10. 400 divided by 1. So it comes out to be T is equal to 2.303 into T half divided by 0.693 into log base 10 for 100, which comes out to be 3.323 into, for half-life this is 12 days, into, for log 400 this is 2.602. So finally this answer comes out to be 103.76 days, or approximately this is 104 days. So the lab should be kept closed for this much duration of time. And this is the answer for the second problem. Thank you.